Hi, I'm Jim Watson, and I've been a SAS trainer since 2003. A while ago, I delivered a webinar on date and time values in SAS. Here is some interesting content from that webinar. I hope you enjoyed this clip. Have a great day. You can indeed manipulate your dates and compare them, and you can do it with perfect safety, as long as you use the applicable SAS function. And of course, we go into this again in programming level 2, where we focus a lot on things like dates. So there's two main functions I want to discuss at this stage. INTNX is basically a date arithmetic function. It increments a date or a time value by a given interval. That would be the first argument. And of course, the reason why you would use this is because the interval in question was not a fixed size. And it returns a date or a time value as the case may be. So the interval comes first, and these are normally pretty thoroughly spelled out, as in you can actually tell the interval just by looking at it. But they often come with a multiplier and a shift index. Shift index especially I find extremely useful. The multiplier merely adds extra intervals, but the shift index actually changes the start position of the interval. More on that one coming up. You'll need a date, obviously, the start from date, and you'll need an increment, which is an integer. I'm afraid it's integers only. So, but that integer can be 0, in which case you give the interval within the current date, or it can even be negative, meaning you're actually subtracting intervals from the date. The alignment, well, you can only get one date from this. The alignment actually decides which date that is, the beginning, the middle, the end, or maybe even the same date. INTCK, by the way, uses the exact same intervals of INTNX, but its role is to compare two dates and work out how many intervals between them. Because of the way it works, INTCK always returns an integer value, because all it does is start from the start date and count all the way to the end date how many intervals changed during that time. So it uses the same intervals with the same multipliers and the same shift indexes as INTNX, but it's also got an additional argument we'll be investigating called method. Yeah, and of course, what they have in common, they both use the same intervals. Now, of course, there's quite a few intervals, and you can also define your own intervals if you find yourself in some sort of special case, but we don't actually cover that in any of our existing training courses. So intervals used, these are some of the more common ones that I've found and I've used myself in the field. Now, I've never actually used day or week, by the way, mostly because I don't see the point. They're fixed in size, so I don't see the benefit of using INTCK or INTNX over just arithmetic, but weekday, 10-day, semi-month, year, quarter, and semi-year are all variable in terms of their period. So therefore, they're very useful intervals when it comes to either comparing dates or incrementing dates. All these date time intervals you see there are only for dates, but any of them can be made to work for a date time value by adding dt as a prefix to the interval. Year would work for just regular dates, but dt year will work for date times. Basically, we're just telling the system to expect date times so it can adjust the calculation accordingly. Most intervals allow a multiplier and a shift index. They almost always do. Now, by default, the multiplier is 1. So if you say year without a number at the end, that would mean it's a single year. But if it's year followed by a 2, that would be a double year. This works for most of the other intervals as well, such as week 2 is a fortnight. You probably get the idea. But I find the shift indexes extremely useful, primarily because they shift the starting point. And if you consult the documentation that comes to this presentation, it will actually tell you when you use a shift index, what are you actually shifting to? So a good example of that would be, say, the year interval. If you use a shift index upon a year, then it shifts to the sub-level, which is months. Why does that matter? You're about to see in the next demonstration. But I also want to briefly discuss the alignment, because this actually tells you which particular date it should return. It can only return one date, and that would be somewhere within that period. B for beginning is the default, that's the first date of the period. E for end, the last date of the period. M for middle, which is as close as you can get to the middle date. And finally, S for same day, which could be very useful for, say, calculating anniversaries. INTCK has a unique argument, though, called method. Basically, it establishes when the start interval begins. I'll show you this in the upcoming demonstration. But yeah, the D for default can actually give you a higher number of interval boundaries than continuous, mostly because it redefines when the period begins in the first place. More on that one coming up in this demonstration.